Hi, and welcome back to a brand new video. In this video, we're going to be talking about the difference between ionic and covalent bonds. So just as an analogy, let's say two siblings, let's say sibling A and sibling B, just got a new boat. The ideal situation is that they both share. So maybe one in time, like for 1 hour, person A has it, and then for hour like 2, person B has it, and then they share. They both equally get time on the toy. This is what we call covalent bonding. When both nucleus or atoms, or I guess in this case siblings, both get the electrons the same amount. And I'll be talking about like the diagrams just in a bit. But we all know how siblings really are. One takes the toy all for itself. And then obviously it's going to be happy because it gets the toy all the time. But the other one is going to be sad. So one's going to be in like a positive mood and one's going to be in a negative mood. And that's what we call ionic bonding. When one of the atoms or the nuclei, or in this case a sibling, takes the electron for itself. But the one difference is that in ionic bonding, the one that takes the nucleus is actually negative, and the one that doesn't have the electron is positive. But that is maintaining the basic analogy. But the thing is that both of them are still in the end happy because they are able to reach stability. And that's the ultimate goal of these bondings. They're supposed to be stable. And by stable, I mean that the outer valence electron shell. So for example, we have something like this, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So if we have like a nucleus kind of like this valence electron shell here, this one's full. So it has 8 electrons, and that's what we call the octet rule. The atoms want to have their valence shell be full electrons. So if for example, if we have A has 9 electrons, and no, actually, let's say A has 7 electrons and B has 9 electrons. If A steals an electron from B, then that makes 8 and 8, so they're both happy. So let's take a look at atoms. For example, in a covalent bond, if we have chlorine and chlorine. So chlorine has 7 valence electrons. So I'm just going to do 1, 2, 3, 4, 5, 6, 7. And chlorine also has 7. And in order to bond, if they both share this electron, then they'll both have 8. Let's see how that works. So I'm just gonna, this one's going to be orange and this one's going to be yellow. So if this is the orange electron from this one, and then that is the yellow electron from the second chlorine, as you can see, if they both share one electron, this one will have 8 and this one will have 8. So by sharing an electron, they can both be happy. And this is why it normally occurs between nonmetals. So chlorine is a halogen, it's a nonmetal, so that's why this works really well. Ionic bonds happen between metals and nonmetals. Because the idea is that, for example, if we have something like potassium and chlorine, potassium has 1, chlorine has 7. So if chlorine takes this electron from potassium, then K, or potassium, will have an outer shell. It won't be this shell, but it'll be the next one under. Because for a, let's say potassium has two shells. The first one's going to be the like two valence electrons with helium, and then it's going to be an outer one. So if this one's taken, then this is now the valence shell, right? This one right over here, and that's full. So that's why it's happy. So if chlorine takes it, then this becomes positive because the nucleus with the protons in the middle, that's positive because protons are positive. So if there's more protons than electrons, because chlorine took its electrons, it's going to become positive because there's more positive than negative charge. And then the chlorine is going to become negative because there's more electrons than protons. So then these opposite charges attract and they become together. And that's how you form something like table salt when you have AA, Na, and Cl. So this positive charge, you're probably going to hear the word cation. Cation just means positive, and a way to remember that is that they have pause, so pause for positive, and then for negative, there's something called an anion. And I kind of remember that I don't like ants, so ants are negative for me, so anion's negative. So hopefully this video kind of helped you learn the differences between ionic and covalent bonds, and see you in the next video.